Hello everyone. In this video, I'd like to talk a little bit about some basic terms in geometry. So to start with, geometry is what we call an axiomatic system. And what that means is we lay out a couple foundational rules and a couple foundational terms, and then the rest of the system, the rest of geometry, is built off of those. So in geometry, we have two different kinds of terms. We have undefined terms and we have defined terms. Undefined terms are the ones that we can't use other words to describe what they are. This is our starting point. So we need something to begin with so that we can start building our geometry. Defined terms are going to use terms that we already know, the ones that we already defined earlier in geometry. So let's start by taking a look at those undefined terms, right? These are our beginning building blocks for geometry. Our three undefined terms are point, line, and plane. So the first one, a point, this is something that has no dimension, and the way we represent this is with a dot. So when I'm writing this and drawing a point, I can put a little dot. Now, I did say in the description that a point has no dimension, but when I look at the point that I've drawn, it definitely has some area. It has a little bit of width, it has a little bit of height. However, this is just a representation. This isn't actually what a point is. A point has no dimension. If we were to draw it, we wouldn't be able to see it. But in our physical world, our representation is just a dot. Now, the notation that goes along with this, the way that we name points, is with capital letters. So I could say that this is point A, capital A. When I'm writing about points and I want to explain something about it, we just use that capital letter to name it. I don't need to put a little dot in front of it. I don't necessarily need to say point A. We just use capital letters to describe points. Now, the second undefined term, a line has one dimension. It extends infinitely in two directions. So if I take 2 points, any 2 points in space, and I connect them together, we get a line. So through these 2 points, we can draw one and only one line, and it extends infinitely in both directions. So to indicate that, we're using little arrows on the end of our line to show that yes, this does go on forever. Just like we did for the points in the first one, let's label these. We can say that this is point A. Let's call this one point B. And now the way that we name a line is based on the points that it goes through. So in this case, it's going through points A and B. So my notation, I'm going to put those two letters right next to each other. And then to indicate that this is a line, we're going to put a double-sided arrow over the top to show that this is a line that goes on forever in both directions. And the last undefined term is a plane. Again, going one step further, a plane has two dimensions. It extends infinitely in all directions in two dimensions. So imagine a flat surface that extends forever in all directions in two dimensions. So if we want to represent a plane when we're drawing it out, it can be a little difficult because we can't draw it going on forever. So the way that we represent this is with a sort of parallelogram shape. But what this is supposed to be is supposed to be the plane, and it's sort of representing it three-dimensionally on our flat surface. So to make a plane, it takes 3 points, and then the plane passes through all 3 of those. So let's name these. Let's say this is point A, this is point B, and then this is point C. So it's like we have this flat surface, and then on that surface, these 3 points exist. Now, this surface does extend forever in all directions within those 2 dimensions. Now, if I want to name this plane, just like with the line, the way we name it is based on the points that it goes through. So it goes through those 3 points, so I'm going to put them right next to each other, A, B, C. And that's it. I don't need to put anything in front of it. As long as it's the 3 points right next to each other, no commas in between them or anything, and that represents our plane. Now, I do just want to note one thing. There are 2 other ways that we can name some of these, and that's if they're labeled. So for example, if this line is labeled as L, normally with a cursive lowercase letter, we can also just refer to this as line L. So I can just say that's line L. Similar for planes, sometimes you'll see them labeled with capital cursive letters. So maybe this one is labeled as capital cursive R. Within our little plane, our representation, they'll put that R sort of tucked away in the corner. So I would be able to name this as just R. Okay, so those are undefined terms. That's the beginning of geometry. Now that we know those, we can use these terms to define some other ones. So our first initial defined terms, I have segment, ray, and opposite rays. And I hope that you see how these are related to what we began with. So the first one, a segment consists of 2 endpoints and all the points between them. So if we think about how this is built, we have 2 points. So 1, 2 points. And the segment consists of everything in between those points. So let's connect them together. We'll start here, and it ends at that other point. So if we relate that back to what a line is, a segment is a piece of that line. So it doesn't go on forever, it does stop. We have some points, so let's name these. We'll say this is A, and this is B. And now the way that we notate a segment is based on the 2 endpoints. So this is segment AB. And to notate that this is a segment, we put a little dash over the top. No arrows here because it doesn't go on forever. It stops at A and it stops at B. Okay? The next one is a ray. A ray consists of 1 endpoint and then all the points going in one direction. So we start with at 1 endpoint, and now this ray is going to extend on forever in one direction. So we'll start here, and then it goes forever this way. And here I am using an arrow because I do want to indicate that this does go on forever in this direction. So we'll call this A, we'll call this one B. And similar to a segment, the way that we notate this, we use those 2 points, we use the endpoint, and then the point is going through. And now to indicate that this is a ray, we're going to put a little arrow on top. And the direction that arrow is important. I started at A, and then it goes on forever through B. So I need to make sure that my arrow indicates that as well. So it's starting at A, and it's going through B, and goes on forever that way. All right, the last one, opposite rays. This is 2 rays that go in opposite directions. So what we have is they have a common endpoint in the middle, and then they go in opposite directions. So one we'll draw going to the right, and then the other ray goes directly opposite to the left, like so. And the ray will pass through a point over here, and it'll pass through a point here. So the way that I define this, I said point C lies in between A and B. So both of these rays start at C. one of them goes through A, and then the other ray starts at C and goes through B. So in this case, my two rays, I'll name them CA, and again, it's a little arrow. And then my other one is CB, starting at C, going through B. All right, so those are some defined terms. Now the last thing I want to mention really quick is just how important this notation is. So as you can see, our segment, our rays, and even our lines, they're very similar in the way we notate them. They're all based on 2 points. The endpoints are the points that they go through. The only difference is the little symbol we put on top. So pay attention to this notation. Make sure you're using the correct symbol because we don't want to represent something that's not true. We don't want to talk about something that we're not meaning to. So make sure that you're indicating whether it stops, whether it goes on forever. Make sure you're talking about the correct thing. Thanks.